it is, acceleration is 0 from A to B. Not the one I meant to hit. At B, it is negative. And so we've got this sort of a funky little thing here about at what point do I veer off of it. Ideally, I'm going to come along here and just a hair's breadth before B, I'm going to go into the negative region. That's what I'm going to attempt to do. I understand that it's sort of a nebulous thing. The reason why I don't want holes is the four things I'm looking for when I grade this. 5 things. Are these functions? At any point, is it 2 places at once? Is it continuous? There shouldn't be any gap in there. And the people who put in the hollow circles, it depends on how it's done, but I've seen people do the hollow circles and then suddenly there's a jump. So they'll do a, like this, they'll put the hollow circle there, and then they'll come down here and there's a gap, and there shouldn't be a gap. So those are 2 things. 1, does this match what you had for the previous answer? And is this consistent with that based upon slope? Is this the slope of that? Is that the slope of this? Those are the things I'm looking for. Is that 4 things? 5 things? 4. Oh, the 5th thing. No sharp corners. And I tried not to do it here. I tried to add, but not my best artistic work. There should be a transition.
Oh, you mean like a straight up, like 90-degree angle or something?
Yeah, no, I would take off of that. I would not take off of that. So that's what I'm looking for. In the instructions, this is known as, is it differentiable? That's just the fancy language. For those who have had calculus, you'll be familiar with it. For those who haven't had calculus, it just means no sharp corners and no gaps. All right. It's not a happy look there, Kristen.
Well, I'm just glad something finally makes sense.
Questions?
I don't really know if the question's gonna make sense.
Yeah, go for it anyway.
So, I see why the velocity graph is flat when the slope of the acceleration graph is 0. So you have to do the same with the velocity graph.
Right.
But I'm having a hard time connecting the velocity graph to the distance graph or
Position graph?
Position graph.
When the slope is positive here, I have a positive velocity. I'm moving in a positive direction, so my position should be getting more positive. So in this region right here, my slope is positive the entire time. Sometimes it's flat, which means my velocity is not changing, but it's curved where velocity is changing. So from here to here, velocity is positive the entire time. I should be moving in the positive direction, which I am. At G, I'm moving in the negative direction, so my position starts becoming more negative. Less positive than more negative.
Okay, well, I might have made more sense with my question. So, when it's flat on the velocity graph, due to the acceleration graph, on the position graph, it's like, it's flat, but it's still...
Right, it's a line segment.
Yeah, okay. So it can be flat, but still be going positive.
Yes,
Right. Just not curved is what you...
correct. And you can see from the crudity of this, I line this out as if each of these time increments was the same, and that's not the case, and so it does get kind of squished and distorted, but get close.
So I guess in that way, the position graph is also connected to the acceleration graph.
Absolutely. And for those who've had calculus, This is the second derivative of that. The acceleration graph actually indicates the curvature of this, that when the acceleration is positive, the curvature is like that. When it's negative, the curvature is like this. And when the acceleration is 0, there's no curvature. All right. So let's run through some analytic problems. This is all more conceptual. All right. So basic uniform acceleration problem, which means we can use the cake formulas. Ball is initially traveling at 30 meters per second. Under uniform acceleration, the ball is going negative 10 meters per second after 10 seconds. Actually, I'm going to change one of those numbers. Let's make this 8 seconds. I don't like using the same number twice. After 8 seconds. So what is the acceleration? What's the displacement? What's the distance traveled? What's the average velocity? What's the average speed? I recommend that when you are dealing with this, there are 5 basic quantities that we are looking at here. There is displacement. There is initial velocity, final velocity, acceleration, and time. If I know 3 of these, I can find all 4 of them. So what do we know? What is given in the problem?
The initial velocity.
All right. 30 meters per second. What else do we know?
The final.
Negative 10 meters per second. And
Time.
8 seconds. So I've got 3 of them. I can find the other 2. So acceleration and displacement, simple enough. Now there's 4 cake formulas, or 5 if you're looking at a different source. So I've got my 2 velocity ones, or my 2 V's. So V final is equal to V initial plus AT. VF squared equals VI squared plus 2A dot delta S. And then my two displacement ones, displacement is VIT plus 1/2 AT squared, or displacement is equal to VI plus VF over 2. So if I want to find acceleration, which formula would I use?
The last one?
To find acceleration?
The first one?
Yeah, we can use the last one to find displacement, but to find there's no A here, so can't use it to find acceleration. First one, I know VF, VI, and T, so yeah, that works. So I got negative 10 is equal to 30 equals 30 plus A times 8. All right, so just basically plug and chug. Units? Yep. So we've answered the first question. Displacement. We now have acceleration, so we actually could use either of the, actually we use any of these three, but let's go for this one. Displacement is VI, 30, plus VF over 2 times 8. I think somebody just said it. Thank you. So we have the displacement. Recognize that this right here is just my average velocity. If acceleration is constant, that is average velocity. And I go through the derivation in more detail in the videos, which I'm assuming you're going to watch. So my average velocity, well, it's just
10.
so 10 meters per second is my average velocity. Yes, Cooper?
In the second equation, does that read 2A times delta S?
Yeah, that's supposed to be a dot there. And it's more because there's two ways of multiplying vectors. This is known as a dot product, cleverly, because of the dot. The other one's a cross product, and you might take a wild guess about the symbol used in that case. It's not the Christian cross, it's a cross like that. Yeah, so it is multiplication there. And average velocity, oh, we just found that. Or we could have done 80 meters divided by 8 seconds. The distance traveled. And we are running low on time here. I'm going to zip through it quickly. Recognize that I'm starting at some spot. I'm just going to make that the positive direction. I go out and then I'm going to turn around. At some point I turn around. I know I end up 80 meters from where I started on the positive side. At what time do I turn around? Well, I'm going to turn around at 6 seconds. Yeah. If my acceleration is negative 5 meters per second squared, I start at 30. After 6 seconds, I'll be at 0. So 6 seconds to go from 30 meters per second to 0 meters per second. I can find my displacement there. Well, I can use this the same equation right there. I get 15 times 6, which is 90. So I traveled 90 meters until I stop, and then how far do I travel back? Yeah, because I end up 80 from where I started. So the distance traveled is 100 meters. So my average speed would be 100 meters divided by 8 seconds, which is 12.5. Just a fun little problem to kick off the weekend. Or to inspire you while you go to work. Have a wonderful weekend. Oh, great. Stop this.